Good morning, mathematicians. How are we all doing today? What to talk about? Two things that are on my mind are actually whoa. Two things that are on my mind are making learning how to do math animations, which is probably the less interesting thing for you guys to watch me do, is to look up how to use Manim or something. But it would be a good use of my time in order to make cooler animations for this channel. The other thing we could do is maybe go look at Lean, maybe go look at proof assistance. I don't know. So, yeah. Proof assistance or teaching myself about math animations. What do you guys think? Let me know. Maybe let's just start off by going to our old friend archive. How was the Saturday stream? I feel like I understand less about infinity categories than I did before. Greetings, programs. Oh, I like that. Proofs as programs, propositions as type. Good morning, Arad. Good morning, Arad. Hey, this is cool. Let's check this out. Quotient branching laws and Gauss-Prasad relevance for general linear groups. Let's check that out. This paper proves the branching laws for the full class of unitarizable representations of general linear groups and non-Archimedean local fields, extending the original notion of Gauss-Prasad relevant pair for Arthur-type representations. In particular, we showed that if pi and pi prime are any irreducible smooth representations of GLn plus 1 and GLn respectively, and their Langlands data or Zelivinsky data are given in terms of multisegments, then through an algorithmic process we can determine whether the Hom space is non-zero. Finally, when one of the representations is generalized Spee, we give a complete classification for the other one for which the Hom space is non-zero. Okie dokie. Let's look into it then. The coffee I made is terrible. I don't have my usual equipment with me. And so I improvised. And yeah, it's not the greatest. The stream seems right up your alley. Wait, whose alley? My alley? Wait. Were you talking about Schrodinger Cheshire cat? So F is a non-Archimedean local field. Pi is a smooth, irreducible representation. The study of quotient branching laws predicts whether an irreducible representation appears in the restriction. We have a multiplicity 1 result. Oh, you're talking about the paper. Oh, this seems right. I don't know why I read that as streams. I don't know why I read that as streams. Probably because I haven't had enough of my coffee. My bad coffee yet. I gotta figure out my new seating arrangement. Should I do this? This seems good. Oh, wait. Maybe something like this. Okay. Maybe this works. It's natural ask when this is non-zero. I see. Because if it's non-zero, then it's 1. Okay. It's been studied in all of these places. Studies it in full generality. Further, there are some recent interesting studies on Ext branching laws following the work of Prasad. I should go check out all of those papers. Yeah, I wonder, is there a way to apply the Kasdan-Lustig theory to this? Is there a way to apply the Kasdan-Lustig theory to this? Ultimately, it seems no, because on the geometric side, there are ways to talk about going between groups and stuff, but it seems like the natural geometric operation should correspond to parabolic induction and Jacquet restriction. But this is a different kind of restriction. Although, who knows? Who knows? Yeah, actually, this is interesting. I mean, what can be said if you take this restriction? I wonder what are the... Yeah, if we know anything. So actually, maybe we'll learn about this from this paper. Something that I would be interested in is, I guess we'll get it for this paper for GLN, is to think about what can we say about the Langlands parameters. How must the Langlands parameters of these things be related? How must the Langlands parameters of these things must be related? Yeah, yeah, that's fair, Rod. Will I not read any of them? I feel like there's actually a reasonable chance I will read some of these. Let me just look at this little trick. I put them here, and then I scroll to the bottom. Yeah, that's good thinking. I could see what these are. The first one's what? Castleman-Shahidi, probably. Nope, totally wrong. Chan and Savin. Vanishing X theorem. Yeah, okay. I guess I should start with the ordinary branching laws. Okay, and we got Cha 2, X multiplicity. We've got CAD, QAD, CAD 2, non-tempered X branching laws. I'm guessing, yeah, I think Prasad proved some things about tempered ones. Archimedean Bernstein-Zelinsky theory? Excuse me? And CQ. What's CQ? Hang on a second. Archimedean Bernstein-Zelinsky theory? Excuse me? What is that? And actually, why don't we make another poll while I'm here? Well, hang on. Let me read this. We developed the Bernstein-Zelinsky theory for quasi-split real classical groups. What? Jacquet functor for real groups? Yeah, I guess. But what do they mean about Bernstein-Zelinsky theory? Derivatives? Excuse me? Do we have a TLDR on branching laws? I mean, TLDR branching laws is basically just how does a representation behave upon restriction? That's basically what branching laws means. You restrict a representation to a subgroup, and you see how it splits up. That's pretty much it. Okay, this is interesting though. Oh, what's going on here? Fourier transform along Vn orbit. This is all very interesting to me. Okay, but actually, let me make a poll. Let me make a poll here about live streams. Where do I go? Community posts. Text poll. Option 1. Lean/proof assistance. Option 2. Math animation package. Math animation software. You don't think you have a good answer for my question from the other day? Oh, about the point of about the authors, in the author's opinion, what the point is about taking the hierarchy. Actually, maybe I should just email him. That's what I was thinking. Maybe I should just email him. I've also gotten more responses. I don't think there's anything new on the Stack Exchange post, but there was some more discussion on Twitter. Maybe I could be coming around. To, I mean, it still seems like perhaps the nature of our disagreement is somewhat philosophical, but I could be coming around somewhat to what you and Leo are saying. I must meditate further on this, though. Which would you rather see as the next mini series of live streams where I teach myself a thing? Lean/proof assistance or math animation software? You suspect you need the hierarchy if you try to define functor categories. Right. Okay. Functoriality in the categories. I see. Reether? Torgierl says Reether? Or did you mean to say neither? You don't want to see either of these two things? Okay, well, let me edit the poll then. Maybe, okay, maybe. Let me put, okay, let's go here. What would you prefer to see as the next live? Why am I making this poll live? This is not interesting for you guys. It's because I'm a busy man and I don't have time to do this later. Good morning, Raymond. Would I Reether? Oh, I said Reether. I understand now. Well, I've removed that entirely. But now I will put another option anyways. Lean/proof assistance, math animation software, Manum, ? And neither. Suggest below. Right? Neither. Hello, Mandrake. Your friend wants to do his master's in algebraic. Your friend wants to do an algebra. I'm just messing with you. Do you know anything about the job market in this? Wow. I mean, the job market for math is terrible in general. So. I mean, algebraic topology is a pretty big field. There's a lot of places you could, lots of things you could do that would technically count as doing algebraic topology. So within math, yeah, it's not terrible. And of course, there's like applied aspects of algebraic topology as well. So, yeah. Let's go make a Twitter poll. Does anyone have any idea why every time I come to Twitter it is completely zoomed out like this? Just wondering. Theoretical physics is a study of where did the minus sign go. My master's thesis should have been subtitled, Where Did the Minus Sign Go? Literally, me and my supervisor spent like hours in a coffee shop one day trying to figure out where a minus sign went. Lean. Math, animation software, Manum, question mark. Well, okay, I'll just leave it at that. And neither. Did I spell it correctly? I don't know. Oh, we gotta ask the question. What would you rather see me teach myself in the next live stream mini-series? There we go. Or let's say suggest below. Would you rather? Yeah. Nailed it. Okay. What are we doing? What are we doing with our lives? Actually, what were we actually doing with our lives? Well, there's this crazy stuff. Yeah, maybe I should go read about that. I guess I've just never, I don't know why I'm surprised. I guess I'm just surprised because I have not heard about, normally when I hear about Bernstein-Zelinsky, that means specifically non-Archimedean stuff. So I don't actually know what exactly is meant by Bernstein-Zelinsky theory here, but I'm intrigued. Okay. Notion of generalized GGP relevant. In order to find the notion of relevant pairs, we got to introduce derivatives. Pi is an irreducible smooth representation, and sigma essentially square integrable. Then this is a generalized Steinberg associated to some segment. Okay. By this paper, there exists at most one irreducible representation such that this is true, where Jacquet is the normalized Jacquet module. What's the server? Oh, should probably ask this on the algebraic topology Discord server. Yeah, you would get, maybe you'd get interesting responses there. What is the Discord server? It is it is it is here. Algebraic topology. Yeah. I don't know. Can I invite to server? Yeah, there's a link here. There's a link here. But I don't know, Arad might be joking. You should actually you probably shouldn't ask the question there. I don't know. Or maybe you should. I guess it's a good question to ask. But it's definitely probably one of the more professional math servers, you know. There's like very legitimate research level people asking very legitimate research level questions all the time. Yeah. So I don't know. I'm somewhat reluctant to drop the link on stream. Wow, the coffee I made is so bad. Hang on. I can get some more different coffee. Actually, you know what? I'll just be a man and drink the bad coffee. That's what being a manly man is all about. That's what us men do. The answer is just the usual one. Yeah, job markets. Yeah, terrible. Oh, it is. Oh, okay. Well, Arad's got the link for us here. For a segment, we'd find the eta invariant of pi by the following tuple of integers. I don't know what those integers are. Where were these integers defined? Oh, it's the largest okay, yeah. Okay. Oh, and there's a notion of integrals. I didn't know this. Pi being an irreducible representation, the normalized parabolic induction has a unique simple module. Sigma square irreducible. Really? Oh, it has a unique simple. I see. Simple sub. Really? For any pi? For any pi? For any pi? Okay. LM2 and LM3, let's go see. What does LM2 and LM3 say? By Lapid and Minguez. Hey, I applied to work with Minguez. Maybe I should probably send him an email and just say, hey, this is who I am. Yeah. On parabolic induction on inner forms of the general linear group. We give new criterion for the irreducibility of parabolic induction and its inner forms. Oh yeah, we're going deep down the reference rabbit hole. We give necessary and sufficient condition when the data, where this is a ladder representation and this is an arbitrary irreducible representation. And simplify the classification of the unitary dual. Interesting. Very interesting. Where this is a segment representation. Okay, what do they mean by segment representation? Classification. Multi-segments, you love to see them. Who doesn't love a multi-segment? Spay. What else we got here? Left multiplier representations. Okay, maybe I should have been reading section 2. But I think I'm really interested in section 4. First description of the socle of this thing. Irreducibility of this thing. Okay. Interesting. So this guy is always irreducible? No, I find this hard to believe. No, this can't be true. What? Oh, irreducible hospital? Hello, Nikolai. No, that should say irreducible with hospital support row. We started early today. Well, I shifted time zones, so we might be early for a while. Or not. Who knows? Who knows when I wake up? Certainly not me. Yeah. Let's see. Let me get myself more comfortable here. So, you have to adjust your dinner schedule again. Yeah. It doesn't show half of your posts. You can't mention other social medias. Damn. You replied to me further in the thread? What? In which thread? Where? You found some familiar accounts on the algebraic topology Discord server. Makes sense. Yeah, there's a lot. That's yeah. That's where the cool kids hang out. It's true. Okay. Yeah, still somehow I'm having a hard time believing this. That this is irreducible. Right? Because like if sigma is also a z of a different delta where those two segments are linked, then this should not be irreducible. But maybe I'm misunderstanding. Okay, well here they're just describing the socle, so. The second part is meeting consequence. Finally, the last part follows, and it says that this occurs with multiplicity 1. Proposition. Oh, I see. Proposition 4.1 gives a satisfactory, necessary, and sufficient combinatorial condition for the irreducibility of this. Okay. Interesting. That is interesting, which is algorithmically very practical. We can interpret the first part of the proposition as follows. In order to obtain this, one performs Moglen-Walsperger on M until the remaining truncated segments are supported in here. Okay, interesting. Interesting. A sigma. What are you looking at currently? A sigma, indeed. This is what a sigma male looks like. This is how I be on my sigma grind set in the mornings. This is, you are looking at representations of GLN over a non-Archimedean field. Say the p-adic numbers. Hey, what a coincidence! Exactly 10 years ago. Oh my god. 2015 was exactly December 15th, 2015. Exactly 10 years ago today. Jesus. Jesus. Time isn't real. It doesn't matter. Okay. Okay, so we got some things. I should remember this paper. This seems like interesting. Seems like interesting and or useful information to know that these things are irreducible. You're so sleepy. Fair. What a sleepy day. It's sleepy day where I am. Let me tell you that. Let me tell you that. You only understood 2 words in that? Or 1? Yeah. Are there people who actually send their projects on Christmas night? Probably. If time isn't real, you gotta wick rotate, yeah. So unfortunately, gang, I'm gonna have to cut off office hours early. Or not early, it's just gonna be a short one today. Maybe we'll come back to this paper tomorrow, since Book Trailer is kind of interested in it. Yeah, but I've got a tutoring session right away, so I gotta go get ready for that. Yeah, so